As part of our unit on particle physics for International Baccalaureate, there's a few other things that we need to talk about. So what we're going to be looking at right now is we're going to just start out with baryons and mesons. So whenever we have three quarks that combine together, they're going to form what we call a baryon. So common baryons that we would have talked about at this point would be protons and neutrons. They're made up of three quarks. If you have something that's made up of three antiquarks, like an antiproton or an antineutron, these are just going to be antibaryons. And these are definitions you have to know for IB. Like if they ask you what is a baryon, what is an antibaryon, you need to know that baryons are made up of three quarks, antibaryons are made up of three antiquarks. And then we have the combination too where a quark will combine with an antiquark. These are what we know as mesons. And that was a question on an IB exam a few years ago. It was just, what's a meson? Well, a meson is something that has a quark and an antiquark. Now, we've learned a lot of conservation laws in physics. We've learned conservation of energy, conservation of mass, conservation of nucleons, conservation of charge. In IB physics, we just have to look at a few other little conservation rules. So the first thing we're going to look at is this thing with baryon number. So as we know, quarks carry an electric charge. It's usually some fraction of the elementary charge, but they also have another property that we refer to as the baryon number. So to determine the baryon number value of a particle, the rules that we have are as follows. So each quark in the baryon, it's going to be given a baryon number of positive 1/3, and each antiquark, we're going to give it a baryon number of minus 1/3. Now, this might get complicated trying to remember. Okay, well, a quark has a baryon number of plus 1/3, and an antiquark has a baryon of minus 1/3. Well, when we're looking at baryons, a baryon is made up of three quarks. Well, 1/3 plus 1/3 plus 1/3, that's going to give us 1. What this is going to tell us is that every single baryon made up of three quarks, it's going to have a baryon number of plus 1. Same thing with the antibaryons. Antibaryons are made up of three antiquarks, so minus 1/3 plus minus 1/3 plus minus 1/3 is going to give us a baryon number of minus 1. So all antibaryons have a baryon number of minus 1. Now, mesons, they're the fun one. Since they're made up of a quark and an antiquark, their baryon number is always going to be 0. Those are the three primary ones that you have to remember. Any other particle that's not made up of a quark, so like for example a neutrino or an electron, these have a baryon number of 0. Now when we've dealt with reactions in nuclear physics, we've mostly been looking at conservation of nucleons and conservation of charge. In IB, we also have to ensure that the baryon number is conserved in our reaction. So we're just going to have a quick peek at this, just to see how it works. So it's asking, the following reactions do not occur. If they did, a conservation law would be violated. Identify the law in each case. Alright, well we've just talked about baryon number, so let's have a look at baryon number to start with. So I'm just going to use a B for baryon. Now, on the left side, we're going to have a proton. A proton is a baryon, so it's going to have a baryon number of 1. We have an antiproton. An antiproton is going to have a baryon number of minus 1. So we have 1, we have minus 1. Now, what is this going to equal? I have a pion, and I have another pion. These pions, these are both mesons, so they're being mesons. Each of those is going to have a baryon number of 0. And then lastly, we have a neutron. A neutron is made up of three quarks, so it is a baryon. So it's going to have a baryon number of 1. On the left side here, I have 0. On the right side, I have 1. Baryon number is not conserved. So this reaction will not proceed because the baryon number is not conserved in this reaction. We also talked about conservation laws being violated. The only other major one we've looked at this point would be charge. let's just have a look at charge. Maybe it is conserved, maybe it's not. So we know the charge, and we're talking relative charges here. So on the proton, relative charge of +1. On the antiproton, it'll have the charge of -1. And then the pions here, they both have a charge of 0. You'll see for a lot of these mesons, you'll see either a superscript, it'll either be a 0 or a plus or a minus. Those are actually giving you indications of the charge. So this 0 here is telling us these have no charge. So both pions have a charge of 0, and the neutron we know also has a charge of 0. So we have 0 equals 0. Charge is actually conserved. So the law of conservation of charge is okay in this reaction. The baryon number, not so much. Let's look at our second reaction here. So we have a K meson, no charge, gives us a pi plus meson, plus a pi minus meson, plus an electron. Once again, let's look at our baryons. So our K0 meson, that is going to have a baryon number of 0, since it's a meson. We have a pi plus meson. It's a meson, so it still has a baryon number of 0. We have a pi minus meson, still a baryon number of 0. And we have an electron. Electrons are not made up of quarks, so if there's no quarks, no baryon number. Well, in this case, the baryon number is conserved. We have 0 on the left side, we have 0 on the right side. So the baryon number is conserved. That is not the one that's violating our charge rule. Let's have a look instead, that's not the one not violating our conservation rule. Let's have a look at charge instead. So again, this meson, the charge is given to us in the superscript, so we're told it has a charge of 0. Our pi plus meson is going to have a relative charge of +1. Our pi minus meson is going to have a charge of -1. And our electron is also going to have a charge of -1. Well, I got 0 on the left side, and I got 1 plus -1 plus another -1. So I have 0 on the left, -1 on the right. So charge is not going to be conserved. So in this second reaction, while the baryon number is conserved, charge is not conserved. So with baryon number, the main takeaway points we want to get from this, all baryons, anything with 3 quarks, has a baryon number of +1. Every antibaryon, which is something made up of 3 antiquarks, has a baryon number of -1. All mesons, which are made up of a quark and antiquark, have a baryon number of 0. And then finally, anything that's not made up of quarks has a baryon number of 0.